a video present a video presentation, and I want to warn you, the presentation is very short, but it's also to the point and very nicely done. Patty did that with some colleagues in France. Patty's in France right now herself. Um, so we'll look at that there. And then we'll get really into the data visitation itself with getting down to the technical real world of it with Patty, with Lars, with Gavin, with Nana. And and then we're going to invite you all to share your data. Well, first to do quality control with your data through the Fairlease tool, and then to share your data. That's an introduction to the session. I'm willing to give an introduction now to the data visitation for RDA project that we have thanks to a Tiger grant here. Um, I don't have slides for this. I don't think I need slides. I think it's in my mind. But Patty, is there anything else that needs to be said before I say some things about our project?
I think no. We can, even though we don't have slides, I'm putting up the first slide here. If you think that's okay, otherwise I could go back to the agenda.
No, I think it's good. I think right now we don't need any sharing
Okay,
uh, because I'm going to speak without slides, and
okay.
otherwise I might be tempted just to read the title slide and think I've done my job with that. Um, please, please introduce yourselves to one another in the chat. Okay, please do that. Okay, so that we can get to know one another. Also, you can, if you want to, you can put your email address. If you're not already connected with Patty, you can put your email address in there, and she'll connect you, and that means you'll be on the hook for doing data sharing. We hope. Okay, so we have something called the European Open Science Cloud Future Research Data Alliance Artificial Intelligence and Data Visitation Working Group. This came out actually of a kind of pre-Tiger grant. I think it's 3 years ago now. I think it's 2022 when we put in for this support. We received 15,000 euros to put this working group together. And within the working group, the objective was to look at artificial intelligence. Um, and this was just before the LLMs really hit the market and started to become big. So we wanted to look at the role of artificial intelligence within the Research Data Alliance, within the role, how it was going to impact data technologies, and science and academia generally. And we had basically four objectives or four outputs that we wanted to achieve. One was we wanted to put together a guidance document on um, for ethics committees, research ethics committees. And by the way, if you go now to the community chat um, inside your Hoover application, you'll see there's a question on the use of research data or research ethics committees for data and data technologies. Please, please put your experiences in there. If you've had experiences, Lars has put in an experience, Patty has put in an experience. Well, we want to know what your experiences are with this because the RDA is now putting together a task force to look at ethics in the RDA. So that's one thing here. So we wanted to look at research, we wanted to look at consent, we wanted to look at human rights, and we also wanted to look at contracts within the European framework for data sharing. And we had some of the people here who worked on there are there. So we have these four outputs. You can see these on our website, and I'll link to those after I get done talking. And then after having completed these, we put in for a Tiger project in order to look more closely at data visitation, but not just to look at data visitation, to actually do it. And this is really very much thanks to Patty and her company, Lifetime Omics, which is located in Florida. and the applications that she has within the company there. So it's a small company looking at omics data and how omics data can be shared. So that's basically what they're looking at. So we put together, Patty and the AIDV working group put together a proposal for, let's say, how we could introduce data visitation, both as a topic for conversation, but also as a practice within the RDA. Because as all of you know, the RDA is very much focused on, has been focused on, really how we can share data. And data visitation seems to be one of the modalities, maybe the most interesting modality, for data sharing. So it provides, if we can provide a secure platform, a secure environment for people to share data, and if we can make it possible for people to link to one another in data sharing, then we should be able to stimulate this. So the fundamental idea behind data visitation is that we do not move the data. What we move are algorithms that query the data. That's basically what we're doing. So Gavin has data, Fabienne has data. Gavin wants to see Fabienne's data. Fabienne doesn't want him to see his data, but Fabienne says, you can send me some questions and I'll use those questions to query the data. We don't have to move the data. Thus, we probably don't have to redact the data. We probably don't have to anonymize the data. We can only allow the, let's say, the algorithms go in and query the data. So that's the background behind it. We wanted to do this project, this is the last thing I'll say though. We wanted to do this project across the RDA and within the RDA primarily, because we really wanted to make it a community-based, a community-focused project for data sharing. So Patty, is that a sufficient introduction to what you're doing? I won't talk about Fairleys yet, I'll allow you to do that. But I think that, yeah, is this sufficient for you?
I think you did a good work with that introduction. I like it. Thank you.
Yeah, okay, thank you. Oh, that's the first time Patty has been happy with something I did. Okay, that's good. Now, Patty, can you show the fantastic video that you've been doing with colleagues for introducing lifetime omics?
Yes.
And introducing really the project itself. Yeah.
Let's see. Not so easy to do here. Let's see, when I share, I think I have to do a special sharing where I also share the audio and video. I hope you can all hear this. You let me know, share sound. Okay, here, share sound. Optimize for video clip. Ah, wonderful. Okay.
Perfect.
It is no secret that artificial intelligence is revolutionizing research, offering unprecedented opportunities for data analysis and knowledge discovery. We also know that with this power comes great responsibility. So, how do we ensure that AI access to research data remains ethical, fair, and effective? The Research Data Alliance has taken a leading role in AI data visitation, AIDV. Lifetime Omics is also leading the way for AIDV through Fairleys, its AI-powered platform ensuring safe data sharing via data visitation. And this is where you, fellow RDA member, can play a crucial role in shaping the AIDV policies of the future. Join us in testing AIDV policy implementations on Fairleys, our innovative platform, all while providing your valuable feedback. As a biomedical researcher, Fairleys empowers you to manage your research data safely and get rewarded through recognition, collaborations, and funding. Your participation is vital in shaping robust and ethical AIDV policies. that will benefit the entire global research community. Help us drive responsible AI innovation by becoming a Fairlease tester today.
Okay, I have some other things here. Okay, gotta stop this. You could all hear it, right? And see it.
It was perfect, Patty. Thank you.
Good, good, good. Okay, so do we move on to the slides?
Yeah, I think so. I think we should get right into what's most important now.
Okay, let's put it in presentation mode. Okay, so there it is. And I think the first few slides are actually for you, Francis, but you gave already a great introduction. So I'm not sure if we have the outline here for the presentation, for the whole presentation. We're going to have Francis, you're going to talk a little bit. You already introduced DV4RDA, but I think you have 2 slides where you're going to talk a little bit about the policies that AIDV worked on in the past years. Then I'm going to present Fairless and describe what it does and how we're working with Fairless for this project. Lars is going to talk about the system security evaluation that we are working on. And then we have Gavin, who has also something to say about AI and data access. And finally, we also have, last but not least, we have Gnana Bharati, also talking about something similar to data visitation, federated learning in the research sector. So I'm going to continue to the next slide. Francis, maybe you can talk a little bit about this ethical and legal standards for AIDV.
Yeah, thank you, Patty. Yeah. So I've already said pretty much what data visitation is, at least as I understand it. I think it's an open topic sometimes for discussion, exactly what data visitation is. Also, sometimes we see it being called, being referred to as data visiting here. But I think one of the most important things is that it's privacy preserving. And we'll get into that both with Lars and Patty, and probably with Gavin and Nana as well, because that's very important. Privacy preserving, but also in a certain sense, we can say sovereignty preserving as well, which is actually, I would say sovereignty is the overcoupling concept that we have, where privacy comes under that too. Privacy is what belongs to me and what's properly mine. And sovereignty gives us more or less the right or the authority to share what belongs to someone or some entity here. One of the things that's really interesting in our project is with regard to why it matters for ethics and law is that Patty with Lifetime Omics is also integrating our outcomes, or at least testing our outcomes and challenging our outcomes against her platform of Lifetime Omics and against the tools she has, particularly the Fairlease tool for data quality control, and she'll come to that later. But that's very interesting for us because it allows us to test the outputs that we've had from the AIDV working group against, let's say, a real life technology. So it's not just policy, it's not just ethical guidance out there in the air, but it's being tested against it. And at the same time, that technology is able to see to what extent that it complies with, conforms with some sets of ethical standards with legal reference, let's say. So privacy, again, is important here. And consent is important here, accountability and transparency. And all these things we have worked on quite a bit in the past 3 years with the working group, so that's important to us. And then, of course, the compliance with regulations, GDPR, the AI Act, the Data Act, all these kinds of things as well come in here. Particularly also the European health data space, which is not the only health data space in the world, and there'll be many more of them, but within all of these data spaces, not just health data spaces that are being derived and moved around, this probably Gavin will say something about that too. So we're looking at some applications, so bias detection within both data and algorithms, the ability to audit AI systems, which we know from the AI Act is tremendously important, and the ability for cross-border legal compliance. I want to say something too here about data visitation. We generally think of data visitation as a way to query data about questions that we have, in this case, let's say in the health space. So suppose Nana has done a clinical trial in children, and he has come with some outcomes there. And I want to find out from Nana's data how many of those children had severe outcomes and how many of those children had less than severe outcomes. So I can send them a query and get that information. But I could also send him a query and find out how he structured his data and have an idea, and we'll see this with the Fairlease platform, about the quality control, about the use of metadata, and other kinds of, let's say, structural elements that would bring us into the field of quality and compliance. So we can use data visitation not only to learn about the content of the data, but also the structure of the data, and probably as well the value of the data for sharing that data. And I think this is a critical importance here. We have also alignment with other international frameworks, the Universal Declaration on Human Rights, the AI Bill of Rights, and the EU AI Act, and the standards that we did in the AIDV working group, which do not come in the same category as the others here. But I also want to say that this afternoon at 1600 Brussels, Paris time, or at 1400 UTC, we'll have a discussion particularly on those topics, and even somebody who presented these topics to the UN Human Rights Commission. So I'm talking too much, but we did a survey on generative and AI and data visitation. We wrote the guidance for ethics committees, as I said, the guidance for informed consent, an AI Bill of Rights, and very interesting here, and Ngochi is here, she worked hard on this together with Alex, secure processing environments, legal foundations. If you want to see a real legal text and how to write a real legal text, that's it. That's the other one there. Valeria here is here, she worked on the ethics committees. I'm not sure who's here from the informed consent or the Bill of Rights. I forget these things, but that's what we have. Patty, I'll stop here because people want to hear somebody more interesting.
No, that was good. Thank you. Thank you, Francis. Okay, so I'm the next presenter. So let's get started. We have trying to keep here with the time. We see we're good so far. Okay, so you have heard from Francis that we are using Fairlease to bridge policy and practice. Policy refers to the AIDV policy outcomes and that Francis just presented. And practice is Fairlease. Fairlease is the practice. It's a platform that visits data and we are currently using to evaluate those the implementation of those policies. So let's get started with why we developed Fairless. I'm sure many of you are aware of these particular problem. You all know AI is not only data hungry, but it also requires access to quality data. You all have heard garbage in, garbage out. And so the question here is, everybody is trying to work on the problem of data access, but who is working on the problem of scrutinizing the data to avoid any risk of bad predictions, especially in healthcare, or misguided investment in acquiring the data, or even just accessing, downloading, writing the whole process of the data use agreements and so on. And the other problem, of course, is that we're dealing here with health data or biomedical data, and that data is often protected. So our solution is Fairless. It's an AID-funded public registry, data registry, that has two components. It has a public registry and a quality control component or tool that is installed where the data resides. The name Fairless stands for, of course, fair data, and the list at the end, it's because Fairless adds analyzable as the fifth principle to the FAIR principles. So how does it work? We thought about rethinking the data workflow, in which we made quality control the centerpiece, so that when you are looking for data, you can immediately get a report on the quality of the data that you're interested in. So when Francis was talking about being able to query someone else's data, it is not through the actual data visitation that we query, but through the data visitation, we run quality control and submit those results to the central registry, where then you can query those results. So that is how Fairless works. And of course, as I say, this protects sensitive data, as the data is not moved, and only the Fairless quality control data visitation tool is installed where the data is. So here's another graphic that shows the same infrastructure architecture, where you do have the central Fairless data registry, and then you have the quality control tool visiting different types of data to run quality control. And I say here data custodian. The data custodian can be the researcher himself, or it can be some data manager or data librarian, etc., who is analyzing or evaluating the quality control to send the information to the central catalog. And of course, data visitation can happen in many other ways, like with machine learning, visiting data. In this case, this is how Fairless works. Now, more relevant just to Fairless QC, it allows researchers or data managers to run quality control, but also curate their data. It has a little bit of a gamification in it, in that they can improve their data by looking at the different checks that passed or didn't pass. So they fix their data, especially the data dictionaries that describe the data, and then they can run the quality control again. Once they're satisfied with the results, they can move the metadata, the results, to the registry. And here you can see what we have been doing with this project, the DV for RDA project. I'm not naming it here, but that's the Tiger Cascade Grant project that we got in a collaboration with the RDA IDV group. We started with defining the plan, as you can see here, February, March. We recruited volunteers. We also worked on this video, as you saw, for example, and we did a lot of planning to reach different groups that can help us with the project. And very important, we spent a lot of time in the system security evaluation, and Lars will talk a little bit about that. Currently, as you can see here, we also obviously did some preparation for this plenary Birds of a Feather session, and we already found some testers, but we're still inviting other researchers to test Fearless. You already saw the video, so I'm just going to move forward. The demo, I'm not sure how we are with time, but I can give you a few, just a little sneak peek. And all of you, if you become testers, you can yourself take a look. Let me see. I have it open here. So this is Fearless. And as I say, it's a central registry where you can, different researchers can add their studies. You can browse it, you can query it, either by categories, or you can type something here, cancer. So these are the cancer studies, but I want to go, well, and you can click on any study and you can look at it. Or if you're a researcher, you have your dashboard as a researcher and you have your own studies that are described. And the path to the quality control and the data visitation goes through first describing what kind of data do you have and what is the data source. You don't need data visitation to get this information. That, for example, in this for this study, it was saliva. So we collect that in the data registry. Once you have that information, you go and describe some information about your data that also does not require data visitation. For example, here we are collecting information if the access is restricted, if it requires IRB approval, and so on. And we are also support reusing data, as you can see here. And when you reuse data, you can also rate the data that you have reused. So that's another way of getting some kind of control through ratings. And we collect provenance information, what software was used. And in this particular case, it's not so relevant, it's demographic data. And then we run the Fearless QC tool. This actually runs, and you can see this is on the web, fearless.com. And this here, it runs localhost, runs on my my computer where my data is. And so this is the data visitation tool. And in this particular example that I'm giving you here, you have some test data, you have, you have your data, you have a data dictionary. Because it's demographics data, we require the date, given that the age can be different based on what date the data was collected. And then we run the quality controls, and you can see here it passed, and something here failed with the decimal number, and so on. And you do get a quality control score. Then you can fix your data and you can rerun it again. Another feature is if you don't have a data dictionary, we also help you, create a data dictionary, and so on. So that is a quick demo. And if you become a tester, you will learn a little more about it. So we invite you to become a tester. And I'll put up the link in the chat later after my talk. Finally, not finally, but almost, I'm getting to my last slides. I wanted to share with you some of the questions that were asked during this DV for RDA study. For example, how do we incorporate informed consent and reconsent into Fearless? We're still discussing that. How to implement criteria to assess potential risks. We are actually working on that as part of the system security evaluation. Which security guidelines should be used? The NIST 800-171 seemed the most appropriate, and Lars will talk about which of the guidelines apply, because some of them do not apply for data visitation, but a majority do. And it is a very robust regulation or recommendation from the NIH. or actually from NIST, but NIH uses it also and recommends it. And then there are some other questions here that maybe we'll have time to talk at the end. So I'm going to try to make it a little bit faster, so we can have a lively and inspiring discussion at the end. This is our team at Lifetime Omics, and I would say especially Bob has been very busy working for this DV for RDA project, and our software developers in improving the security of the data visitation tool. And I would like to end my little presentation here with a call for researchers who want to pilot Fairless, and also any strategic partnerships with organizations that are looking to curate and catalog their data. Please contact me. The sign up to test the Fairless.com, I'm going to post it in the chat afterwards. And that's it. That concludes my presentation, and I'm going to invite Lars to continue from here.
Thank you very much, Patty. I will share my screen.
Oh, you have it yourself? So do I?
Yeah.
Okay.
It's easier if I.
Okay, no problem.
So as Patty just talked about, we in this part of the testing, we of course needed to look at system security, and from this we have developed a template which you can use when you want to do a similar type of security assessment of a tool of this type, of a data visitation tool. We have used this collaboration with Lifetime Omics to sort of get a practical feel for what we need to look at. Let me show you the template. So the template is a list of sections where you can see what you need to think about when you're starting up a project like this in terms of security. And it goes through roughly the time efforts. Of course, these are guidelines and recommendations that can, of course, take longer time or depend on the depth you feel that you need for your specific system. But it gives you an idea of to start from. Why do we do this? Well, we do this to make sure that when we send code in somewhere, when we send a query in, that of course carries with it a risk to the system that we need to evaluate. And to do this, you need to have a guided plan. The reason we used the NIST 800 171 is that is one such plan. There is corresponding plans within the ISO framework, which is the 27000 series on cybersecurity, which then lets you fulfill the regulations of your region or where the data resides. This is very important because you will need to fulfill cybersecurity qualifications so that the person who is sharing the data can feel secure. That's the point of having a security evaluation and evaluation guidance, that whoever is letting your code in feel secure that your software will not hurt them. First, we did a selection of evaluators based on their need and expertise within the fields, and then follows the different types of scopes and assessments that are needed to generate this plan. So when you select these evaluators, we have called it code evaluators. Basically, these are security experts that will look into whiteboxing your code. Whiteboxing means that you're looking at the actual code that's supposed to run, unlike black box testing where you test the outcome. Then we also have expertise in that, people with expertise within the system security background, which evaluates the actual plan of how to do this. And then you need tool evaluators that will pilot the tool and do black box testing. So you have white code testings, black box testing, and you have people that can evaluate the procedures around security within the organization that handles this tool or provides this tool. And the reason you need to do that is when we're talking health data, we're talking sensitive data, sensitive personal data. If you're in the EU specifically, will have a lot of regulation around it. But this is true wherever you are in the world. So you need to make an exposure analysis. You need to check how big is the risk that the data that resides inside is exposed to the outside through some sort of attack or some sort of exploit of vulnerability. You need to look into things like how is authentication authorization handled, how is dependencies handled, what kind of procedures do you have for following these for following a structured security framework. So when you're working with cybersecurity, one of the most important thing is that you, as an organization or as a tool provider, that you have a structured way of collecting and monitoring threats that is relating to your code or query. Here we'll talk a little bit about the scope of this assessment in the security plan. So for this specific example of the lifetime with the lifetime option, the Fairless specific example, we use the NIST 800-171, which is a recommendation on how to do structured security work, what you need to think about. And we've placed it in applicable and not applicable. That does not mean that the parts in not applicable are not important for the security, but that it is outside the control and scope of the tool provider, in this case, Lifetime Omics. For example, the physical protection of data, since you're doing data visitation, is handled by whoever has that data. And all you need to make sure is that your code does not insert something that would compromise their physical security, like sniffers and things like that, which exists in these applicable parts, right? So within the system and information integrity. and protection against malware. So personnel security, which regards to the people working, the scientists that have the data, right? It refers to that, and therefore it's not applicable. So for not applicable, it's still important, and it's things that you need to think about, but it's not things that you might have control over as a provider of code, because in data visitation we have two entities, at least two entities, sometimes many more, that of who are working together, right? So we have the provider of the code that query the tool, and we have the provider of the data, and they will have security considerations of their own. So while these are important to protect the data, they're not important to test for when you are the query provider, when you are the actual tool that is going in. So for the two people that have done work on the actual sort of nitty-gritty of this, that has been David Mollett and me, with great help from Ronit, Whitney, and Nathan. And this team is a team comprised of people that both have a solid background and experience in computer science, but also in expertise and understanding of these types of security issues that will happen, that are slightly different from a normal software tool, because you are in this mixed environment. That's me. That's what I have. And if anyone wants to lift a few questions, I think we have time for that. Few minutes. Otherwise, I will turn it over to Gavin.
Lars, I just want to say, you and Patty have done a fantastic job in putting in the framework for this data visitation for RDA, putting in the framework lifetime omics, but also very importantly, the secure environment, which I'm sure Gavin and Nana will follow up on because it's so important here. But just, Hugh, I see you've added some notes. Do you want to say anything about that now, or do you want to let Gavin and Nana go first?
No. Don't worry. Let Kevin carry on. Thanks.
Okay, good. Thank you, Hugh. Anybody else want to say something before we go too quickly? Okay, we're good to go. So then, Gavin, I'm sorry, there's no more delaying your task. Please
No worries at all.
share some thoughts with us. Yeah.
Is this showing up okay?
Yes, it is. It's very good. Thank you.
Perfect. I'll get into full screen. Okay, and for full disclosure, I must admit that when I got the invite from Patty and Francis, that I read it as artificial intelligence data visualization instead of visitation, which is really embarrassing from my side, as if I had perceived it as visitation in the first place, the Elixir side could have come through a lot stronger. But I have made a slide to compensate for that at the end. So what I will be presenting on, and just to clarify, I'm a PhD candidate at the University of Padova, working with Elixir Italy, but I previously worked with the Elixir Europe research infrastructure, involved in quite a lot of different EOSC and life science projects. And I'll be presenting on one of our main machine learning AI-focused outputs of Elixir, which is the DOME output from Elixir. So machine learning of the life sciences, I don't need to spend too much time on this, but there's been an exponential growth in recent years of machine learning, artificial intelligence methods being applied to the life sciences using life science data. This is due to the increase in more powerful hardware, such as GPUs, TPUs, and so on, and also the availability of high quality, fair biodata, through the FAIR initiative, which has really, really done a fantastic job getting us to this place where machine learning can be quite effective. This led to some huge landmark successes for life science challenges, and one of those being AlphaFold, which I'm sure most of us being from the life sciences are quite aware, but this allows protein structure prediction in quite an accurate way. But with this, there's been a massive growth in machine learning life science publications growth. So alone in 2024, the most recent year, just looking at keyword matching for machine learning. So not all of these are machine learning methods papers, as there might be papers just mentioning machine learning, but it's a rough estimate of the growth of methods as well included in there. You can see that in 2024, that there was 85,000 new papers in this field, quite a few of those being methods papers as well. So with this, there has been a bit of a machine learning publishing crisis that Elixir has looked to address in a certain way. And putting this in context, the issue that Elixir was looking to address with their DOME guidelines and so on was the poor descriptions of machine learning methods in papers. Again, linking this back to Fairleys and stuff, one of those key aspects being data, where the data is, what the data is, and so on, and that elements of disclosure. And to put this in context, if you were to go into a store and you were looking for a snack and you had two items in front of you, both being yogurts per se, one was very clearly marked with the ingredients, the best before date, and all the other nutritional information, while the other had nothing on it. You might look and think to yourself, well, which of these is more reproducible, transparent, trustworthy in those aspects to help inform your choice? And most sane people would go for the well-annotated one. But this is what we're seeing in comparison in life science publishing. There's no such regulations or frameworks or mandates in place for machine learning publications to help support this transparency, which is quite an issue. So Elixir, the folk came together through their machine learning focus group, and they had this DOME recommendations. So it's looking at best publishing disclosure practices for machine learning methods. So this was published in Nature Methods in 2021. And you can find as well a link to the specifics of this guideline of what should be addressed on fair sharing, which I've linked there. To go through a very quick overview of what it is, DOME is an acronym standing for Data, Optimization, Model, and Evaluation. In the context of Fairleys and this discussion, I think the data one and what should be disclosed through our guideline is maybe quite important, helping again for data visitation. So very quickly, each of these, there's different areas that are recommended that should be disclosed. So for the data, for example, there's a recommendation that you should be disclosing the exact data splits between test and training to avoid data leakage. And again, as Patty had mentioned in her talk, help avoid this garbage in, garbage out, and support transparency. There's also the aspects such as optimization, where you can disclose exactly what kind of algorithm was used in your model, be it a convolutional neural network, a random forest, or so on. The model aspect, is there software availability? Is that linked to? Is that findable? And then on the evaluation side, has there been, for example, comparisons to simpler baselines or different methods in this area using a standardized data set to actually prove accuracy claims and so on? So that's the DOME standard. Building on this, and at my group and what I'm working on with my PhD is this DOME registry service. So it's a database of annotations on machine learning methods papers. So you can come along and annotate your machine learning methods paper and disclose all those elements. So again, thinking of Fairleys, the data aspect of this and what's disclosed can help then for this data visitation aspect of this. And in practice, very quickly, what the DOME registry does is it's a guided template. So for those recommendations that you can then disclose it, we use the DOME wizard, which is based on data stewardship wizard. So you get your standard template and it feeds it into the registry, makes it available for people to see. You get your final score at the end, which is a rough estimate of how transparent and reproducible the methods in paper is of the machine learning methods then. Based on if the box is filled or not. And you can see here for the optimization element of those 4 different ones. For the optimization algorithm, you can see this person disclosed what kind of convolutional neural network they were using. What's the incentive for the DOME registry? Well, we're hoping that publishers will adopt it and mandate it in their workflow publishing, help again on the data aspect, make sure that people are thinking about where they've deposited their data, made it available, whether it's health data, if it's in a trusted research environment, secure processing environment, or somewhere else that people could potentially use for data visitation. Having that clear and findable is very important. And then, of course, we've linked with the Apicuron service. So when you do annotate your methods, it gets pushed back to your ORCID. We do, however, for DOME, the DOME registry, need more policymakers and funders' engagement and interaction to open up discussion how to maybe adjust or reuse DOME, that space as well for them. I won't go into the future of the DOME registry in favor of conversation with this, and in favor of as well the other slide that I mentioned at the start that I put together, which is more of relevance, but this is a general thing of roadmap of what we're looking at next with the DOME registry. We do have some information again in the slides if anyone's interested in this or knows a publisher that would like to potentially experiment or adopt this. Their workflow, we're very happy, and we've contact details as well. But in the context of Fairlease and Elixir, then, so I'd just like to pull out some link points that might be useful, and again, some contact points to support you guys with the AIDV working group, with Paddy, Lifetime Omics, and their platform of, I suppose, existing efforts in this space, again, to support data visitation. And one of the main ones I would pull out is the European Genomic Data Infrastructure project, and again, it's quite closely aligned to the Global Alliance for Genomic Health Products and Standards, where they're looking at chaining together in a starter kit for different European nations to support cross-border genomic data sharing and analysis. I've linked some contacts here from the Elixir Hub. So the project PI, Serena Scollin, Melissa Konopko, someone who's working quite closely on her team on this, who can help then link you in with people in the different Elixir nations, what they're doing in that space. And just to say, they're far from having a unified solution across Europe. There's this guided starter kit of products, but they're not in place everywhere. I've been quite involved with Elixir Ireland recently. And again, one of their biggest thoughts and struggles to start up is to get a secure processing environment in place, somewhere where they can analyze data, and then also even just to get a solution in place for storing genomic data, let alone any other kind of sensitive health data. So those are the two big things a lot of nations are looking at now, but GDI is providing a framework or guidance. And again, they're looking quite closely at interoperability with any solutions where they recommend these through the starter kit, but every country has its own discretion of what they adopt. Something like Fairlease could fit quite closely into this space. EOSC and Trust is a European EOSC project, a much smaller scale of GDI, but they have an interoperable trusted research environment blueprint. The project PI was my old boss, Peter McCallum. I'm sure he'd love to talk or, again, see how you guys can engage, but they're producing at the end of this project in a 3-year iteration an interoperable trusted research environment blueprint, which might be of use again for data visitation, as TREs and SPEs are the cornerstone of all of this kind of data visitation work. Elixir on Cloud is looking at federated analytics. I've linked to one of their GitHubs and proof of concept projects. It's very beta, it's not very advanced, and it's not very polished, something that comes across quite well with AIDV template and the Fairlease platform instead. So you guys have quite a bit ahead in that domain, but they're doing proof of concept, federated analysis across different countries. And then, of course, AI for EOSC is as well maybe another nice link point, but they have their EOSC ecosystem where they're feeding back into it, and they have their own platform for analyzing data. Just to say, I really liked the security angle of AIDV. It doesn't come across closely enough or uniquely enough in any of these things that I've, well, the EOSC and Trust one for sure, but from my experience and exposure to GDI, the security wasn't as clear. I'm sure it's there because especially NBIS is involved and SciLife Lab with GDI, but also Fairlease as well. Just the QC aspect, I've not seen anything like that before, and it's really those two aspects are two key strengths I see you guys having. Some other ones just to mention at the bottom, EOSC Cancer, there's a project there in that space. Again, I can find you link points if you need to see what they're doing or talk to people. In the different countries, they're setting up federated EGA nodes for genomic data sharing on national levels, and again, could support data visitation. Beacon for finding data and doing those queries, as you mentioned, is quite a standard that Elixir's invested in the past and using in GDI. And then just another company initiative, GenXT, which might be interesting. These guys work quite a lot with GA4GH and very open, and might be nice. And again, I can give link points to any of these. So hopefully that was useful with the final slide and redeems me for my mistaken invite. Just to share some of my colleagues, and thank you very much. I'll stop the screen share.
Gavin, that was pretty amazing.
Yes, thank you. Very good. And very, very nice to share the slides. Good you thought about adding that.
Patty, the only thing I want to say about Gavin's presentation is it's absolutely scary because the amount of work we're going to have to do to catch up to what Alexa is doing and to connect with them and all these different facilities that they have. But it's also enormously promising. And yeah, I'm sure Patty and her team and Lars and everybody be really happy to jump on the Alexa bandwagon with you. Yeah.
Just one thing that I will say is you guys, so we get self-described by our new director as having a lot of professor wear. So again, it's a weakness of Elixir. So you guys coming in with these polished platforms and standards and security front and center, it's you guys are not very behind in any capacity. And Elixir as well, just to say they love interoperating, working together and building upon. So I see a lot of scope in this space. And again, I can link you to people who would be able to engage further. I'm not the person, but I can support as a link.
Thank you.
Well,
Wonderful.
Gavin, you're not going to escape that easily. I'm sorry. We need you. Okay, let's go to Nana. Nana's in Australia. And Nana, that's a hard trick to follow what Gavin and Patty and Lars have already done, but I think you're up to it. Yeah. You're on mute. Yeah. It's really not the first time that Nana has used Zoom. I'm absolutely sure of it. Yeah.
Oh,
So
sorry.
yeah.
Yeah. Do you see my screen now?
No, we don't see your screen. We did before, but we can hear you,
Okay.
which we could not
All
do
good.
before.
Yeah.
Thank you. Thank
All
you,
good.
Nana.
Yeah. Yeah.
Now it's
yeah.
perfect.
Thank you. Thank you so much. Yeah. So this is absolutely fabulous session, and I could see a lot of synergy. And I'm going to talk about what's coming from down under. And so this is, and also about the federated learning, which is another perspective of data visitation, you could argue. So in this one, we are talking about a particular issue that we are facing here, which is about unharmonized federated learning that is happening in small and fiefdoms and so on. And then, so what we could do actually to make it better. So this one is about, I mean, these are my contributors, all on the slide. I wouldn't do justice by reading out the name, but you can take a look. But this is a story. So I come from Australian Research Data Commons. We are the data and analytics infrastructure people for the research sector. And one of the NCRIS facilities, among a number of others, each focusing on different areas. Among us, this particular one is focused on the healthcare pillar, also called People RDC for some reason. And there are 4 focus areas, of course, about the discovery of the data, secure research environment, and integration of data. But what I'm referring to is advanced analytics. In order to understand what the research sector was thinking, aspiring, and needing, we did some extensive co-design process. We went through that. And so in that big arrow that will take you through or walk you through at different parts of the presentation is about the systematic and the inclusive process that we had gone through. And so in the beginning, they were co-design. And so this provided extensive information about the needs and aspirations of the sector. And so that included, as you can see in the bottom left corner, various aspects of the infrastructure, diced and sliced in different ways that included surveys, data sets, interviews, and environmental scans as elicitation. Then this was synthesized. And the infrastructure for us, of course, which is quite familiar to RDA, is that it is not just the underpinning infrastructure or the hardware and GPUs and storage, but also data assets and also tools, platforms, and so on, as well as the socio-technical assets such as frameworks, culture, policy, communities of practice, and guidelines, etc. So it's the initial co-design was carried out in two forms. One is a very broad brush approach, which is to cover everything. And the second one is a diving deep. And so both together constitutes overall this framework. And what actually happened was, throughout, a theme emerged. Of course, it's not surprise. And one is a sensitive data being ubiquitous, a challenge in healthcare, but also the barriers to sensitive data, mobility. And of course, federated learning emerged as a promising solution. But we also identified there are cottage approaches to federated learning. And we also identified there are number of socio-technical complexity issues around federated learning. In almost every case, but in this case, particularly so. And so in terms of having this cottage approach, it also meant that it meant it's creating a sort of disharmony and fragmentation in the approach. And so there were multiple isolated implementation, inconsistent platform standards and communication, limited standard pathways because of the socio-technical complexity. It also meant the governance played a big role in anything to do with sensitive data, accessing the sensitive data, and so on. And there is no central coordination. And this meant the barriers to scaling, duplication, and silos, and of course, the lost impact throughout. And so what it, so when we investigated this landscape, so we also invested time in specifically looking at the federated learning as a drill down or a deep dive. And so this identified key challenges around federated learning. And we also brought together, we were lucky enough to bring together a disparate group of collaborators who would otherwise would have stayed siloed. And but brought together, collated existing resources. And then that is how this Pathfinder project emerged. And as Pathfinder project, we developed a demonstrator instantiation of the federated learning, and evaluated a number of frameworks that are available to federated learning, as well as a community. Which of these frameworks perform better, or under what circumstances each of these frameworks could be useful. So this is one of the things that we were evaluating, and then created at least one implementation as a demonstrator, not to recommend one particular approach, but more around as a nucleus to around which we could have this dialogue and discourse. So people could actually look at something that works and then talk about the challenges and so on. So that is So this, as I mentioned earlier, it brought out a number of socio-technical challenges. Only a national organization such as ARDC or somebody in a similar position could actually investigate. And so the outcome of that is, of course, we identified various tools, evaluated them, the infrastructure requirements. We also looked at the TRE, which came up quite often. Where does TRE would fit in a kind of a federated setting? Because in order to hold the data, you need secure, secure environment. But of course, TRE comes with certain specific meaning, because any ingress or egress of data needs to be monitored by humans. And of course, HDR UK is getting around it by creating a hermetically sealed network, so to speak, within which the data could actually move around. And so on. So these looking at these different options and different needs and so on as a community would actually took us to the next step to synthesize everything together. This is where we got the two major study and got into the next stage, where we said, okay, do we draw on this output, and how would a solution or potential solution look like? So this is where this reference architecture came about, which is like a layered cake. Of course, there is underpinning infrastructure. For us, one of the underpinning infrastructure runs on our cloud, which is Nectar. There are a number of existing pieces there, which are shown with underlines, but also required was more extended security certification and so on, storage, etc., that is needed in this sector. But more interesting are the next three layers, which are the enabling tools and platforms and the data, and then socio-technical assets, and on top of all are the virtual environments, virtual research environments, be they for training, for projects, or the custom purposes, and so on. And so this architecture, as you can see, is organized through this infrastructure lens, so that it enables us to build on top of what we have. And it also embeds certain AI capabilities, as we have, which is of course evolving, but including to support training and so on, support training and the capability building, etc., in the form of co-pilots and intelligent vehicles, etc. But the central to that, one of the central pieces is federated analytics and federated machine learning. And so that, as you can see in this box, but they would all be accessed through this virtual environment from, so that is what would be visible to the researcher in many ways. So from this virtual design, reference architecture, we, of course, we translated that into three extensible projects. One of that, or the central to that, is a federated learning network, and which is developing a streamlined infrastructure, both soft and the hard infrastructure, for the health teams to securely deploy and use federated learning across sensitive data and related challenges. The short-term goal is to actually build an infrastructure capacity, fostering for the federated learning community, but the subsequent one is to extend it to democratize and so on. But this is supported by a few other projects, which is like one is a virtual research environment, and other one is a resource hub. Virtual research environment will underpin, which is a deployable environment in different forms and shape. And the resource hub is what would go into this environment, what resources would go in. And also complementary to that are the trusted research environment or TRE projects. And so these different projects come together, but the key part for us is to tackle the socio-technical barrier and the market failure in this case, which others could not actually play in the sense of for-profit organization may not get in as well. And but also it needs to be of national interest and should have some innovation potential. So so this is how this project is. It's actually this is a part 2 or second phase of this Pathfinder project. This now has co-investment from a number of partners as well as ARDC. We are working on it right now to build a national federated learning infrastructure that includes first building a community and expand the technical capabilities and secure an interoperable deployment and a common architecture and but more importantly, or most importantly, governance around it. How could there be a unified governance which would expedite or access to data from different sources and so on? And of course, it cannot happen without support from support in the form of adoption and training, etc. So it's also worth mentioning in this view when we talk about, I mentioned about VREs, virtual research environment. And so which is a continuum, and we see it as a continuum. On one hand, you have an open virtual environment that we can all work with. And on the other hand, you can have secure custom environments, but also trusted research environment, federated analytics using TREs or federated learning or machine learning, which will require very frequent transaction of messages and so on. So the strategic implementation or the strategic value of this is that, of course, it would require it would bring benefits in the form of having, of course, immediate value to the research community and the partners, and but also the intention is, of course, it would result in better patient care on the long run. So that is where so this is where we are heading. But I realize I did not if there are so I did assume we know what federated learning is. Otherwise, this is just a short one sentence introduction where data stays in different silos and the data cannot leave for jurisdictional or organizational policy reasons. And so which means instead of taking the data to a central server, you actually take the model to each of the nodes and only transmit the model information and consolidate and create the whole picture using these pieces of information. So with that, I will stop my presentation, but I do want to also take this opportunity to welcome you all to Australia in the second half of the year, in October to be precise, when we would have this IDW, and about which I just posted in the chat. And we expect to have health data common session in IDW. So please participate, and there would be a number of other sessions as well. Thank you.
Well, that is unexpected, but it's very nice that you end with an invitation to dinner in Brisbane on you
Absolutely.
in October. That is really nice.
Yes.
I know Patty's going to be there. I imagine Gavin will be there, and Alexandra will be there, and others will be there. So we'll all go out to dinner with Nana,
Yes, indeed.
because it's a little bit far from Sydney where you're living. I think for you to cook at home, but we
Yes.
can all go out for dinner. No, thank you, Nana,
Yes,
for a great
indeed.
presentation. Thank you for the invitation to Brisbane. And I'm actually glad you mentioned Brisbane because we are really heading towards Brisbane with this project. The end of this project, I mean, there's two things that are going on in this meeting, really. We wanted to consider for birds of a feather. I think we'll actually come back to a full consideration for the birds of a feather when we get to Brisbane and we get to dinner with you. But because that's also the end of the project, more or less, that's where we will deliver our deliverables. And then at the end of November, we have to report the project back to Tiger in order to complete the project and actually get the money too. So that's how it's going then. Patty,
Yeah.
should we stop here or we have time for discussion for 10 minutes at least? Yeah.
Yeah, we have a few minutes, 9 minutes for discussion. And I'm really grateful for this wonderful, speakers, Gavin and Nana, that are sharing your work. Definitely there's a lot for us to research with Elixir and the different organizations that we can collaborate in. And with Nana, there's a lot to learn in the infrastructure that you're developing there for the Australian Research Data Commons, and see where data visitation fits in. I know there are many similarities with a federated system. So definitely many points of discussion. I'm still processing it all, but and then we had some questions that maybe
Patty,
we wanted to address.
Patty, I'd like to start. There's a question from Ashish, who's first, but I'd like to start with Alexandra's question because I think this is really important. Alexandra, do you want to pose the question, perhaps?
She can't now, but
Okay.
I think it was the second question, maybe the one where she asked if this is only for biomedical data or also social data, right?
That's right. Yeah. So Patty, this is a really important question for our project too. Are we limited only to omics data, to biological data? Could we also do a test run, for example, with data from psychology or psychiatry in the field in which Alexandra is working?
Mm-hmm. Well, first of all, psychiatry is still health data. So that applies. It covers it. Now, social sciences, we don't support social sciences that don't deal with any health factor, right? If it's just anything, you can do social science with political, environment, etc. At this point, we don't have any implementation for that, but we can always adapt it depending on demand and if there's funding for that. But we support social sciences if they deal with any health data, and there are many examples of that.
Very good. So could you put in the chat the link for the call or for where people can contact you and set their to get involved with the actual project itself? You have a link for that, I think.
Yes, I posted it earlier. I can post it again, and I also posted a link for Alessandra, of our FAQ that actually answers that same question. We have a question in the FAQ called "What is the domain of research that Fairless covers?" So,
Okay,
and
good.
I
So
have the
post
link
those
there.
two.
Mhm.
Yeah, post them in the chat, please. And then Ashish asked two important questions too. The first question is, to what extent does this relieve, I believe, the human in working in this? And the second question was, do we have other considerations when we're dealing with less resource intense areas in the world? Ashish, do you want to reformulate that in a better way?
Yeah, basically, since we are a project group which looks at frugality, which is aimed at access, access and affordability of innovation. Now, I've been trying to assess the machine learning, natural language processing algorithms, trying to get a feel of how it actually means and what are the informational needs. So primarily, I was just trying to hint at whether it is about the developer of such applications that lack, capacity to deal with the full potential of data visitation, or is it that the very design of information processing for data visitation is currently a problem? So that was one part about the capacity issues, and of course, further contextualizing in the context of developing countries. Health information systems are typically fragmented, and the deployment of AI is currently low. There are individual successful cases, but I would assume that data visitation requires a level of deployment of AI before data visitation can be implemented. So if I'm correct in that understanding, then probably data visitation is a limited prospect, is what I was hinting at.
That is a great question that we have actually discussed in our team, and because our goal is to be inclusive of the registry. Fairless registry is supposed to be a registry for the entire world and researchers everywhere, and we know that many researchers need more access to technology and training and help. So regarding your question, access to AI, one of the things that we have done is we do help researchers that are doing the data management aspect of the data and the data curation with some open AI tools, some AI tools that help them develop their data dictionary if they don't know how to do it. And it is also in the plans to have more of an assistant. So have AI as an assistant helping them manage their data. And now our use case is a little bit different with, for example, Gnanas, who is directly doing machine learning analysis, which we will tackle later. That's a little bit different because it would require, if you have a lot of data, high performance computing. So I will let Gnana answer because I see his hand is up.
Thank you, Patty. It's partly I was the hand went up partly in support of what you were saying, and but I wanted to add yes, for the machine learning itself, it's not the AI technology that would be the most limiting factor. It is mainly putting up that secure infrastructure. That is with all the security protocols and so on, and secure cloud, or in a way that can be networked and so on in healthcare data. And so that is a limiting factor. Cost of machine learning nowadays is significantly less. Of course, I'm not talking about OpenAI, which is trying to run it on, humongous text data. But for most of the, narrow AI applications that we are seeing here, its cost is limited, except for the actually running that infrastructure. the security, and some GPU, which is only going down quite fast. So that I wouldn't say it's a costly affair, but where I would, yeah. So, but this application has, we are not limiting it to health, as you are doing, Patty, same way. But yeah, we would we have other pillars, which one is humanities, arts, and social sciences has an indigenous pillar, and planet, which is an environment pillar. Both would use it, but this is where we are developing in healthcare, where there is immediate demand.
Okay, thank you. We are actually, I think, at the end of the session. So I don't know if we have any last questions, but otherwise, maybe Francis, you can say thank you to everybody here. This was a fantastic group of experts in this area.
I just,
Yeah.
sorry, can I just
Lars,
make a
please go.
short comment?
Please go, Lars. Yeah.
So, especially for this data visitation, so I work in infrastructure mainly. I started to work in infrastructure, and the concept of data visitation does not just apply to AI. In this case, it's very tightly connected to AI and data visitation, but it is a distinct thing from AI itself. You can have AI without data visitation, and you can have data visitation without AI, because data visitation will be also highly important in when we're talking sensitive data and this type of queries. And there you have things like that are not AI based, like 1,000 genomes and other types of these types of 1 million genome projects. And these things, they are going to be this typical thing where you have data that you want to protect, and then you want to give out statistics. You also have data visitation is really important in spheres like astronomy and physics and others, where it's not the sensitivity of the data that is limiting, but the size. You can't move the data because the amount of petabytes produced by these systems is too great to move. That if you start moving the data, it takes, all you will do is move data. You won't actually do any research. So data visitation has two very big important things. And I think it's important to know that it is a thing upon itself. It is very, very highly useful in these cases of sensitive, especially sensitive work on AI and untrusted research environments, but it is not limited to that. I just wanted to give that as a comment.
Thank you,
Good
Lars,
point.
for that. That's really important here. I just want to give a shout out to Ryan O'Connor, who's joined us later than I thought. Say here, Ryan is the kind of backbone to everything. He is with RDA Tiger, and it's really good to have him here too. Ronit, it's very important that we have you as well, because she's been part of the AIDV all along, and we're making this work with Patty. It's Patty really who made this session work together with Lars, Ronit, and a few others who are not really here right now. But Patty, you did a great job. I think you need to close the session and let everybody get on with their day.
Yes, thank you to everybody. Thank you, Francis, also for a great introduction, and you're a good moderator. So I think this all went fantastic. Also, you're the one that suggested I contact Gavin and Nana, and so you always have the best recommendations and the best ideas. Good. So thank you, everybody. I think this concludes our session. Have a nice rest of the RDA plenary. I might meet you in some of the other sessions, and especially the one by Francis that is later today.
Great.
Okay, bye.